Okay, so this hopefully short video is about extinction for AP Bio topic 7.11. So let's go ahead and look at some pretty pictures of some rocks. And what I'd like you to notice in each of these pictures are the beautiful rock layers. And when you think about the sedimentary rocks that formed here and how many millions of years it would have taken for rivers to settle sediment down and then for them to harden and form these rock layers. Now, I've traveled across the United States on many road trips, and one of my favorite things is to admire the different rock layers and think about, like, in geologic time, like the history that's represented in those layers. Now, for our discussion, we're going to talk about the fossils that we would find in these different rock layers. Now, these rock layers are called strata, and as you can imagine, the oldest parts of these layers, or the oldest layers, are going to be near the bottom because those settled first. And then as time goes on and you keep on bearing, the youngest strata will be near the top. So in these different layers of rock, though, we can see fossils, and that's our fossil record. And we can find times of rapid kind of like speciation, when lots of new species diverge in the fossil record, and we can also see times of extinction. So that's really what we're going to be talking about. So, here's a picture of me. Like I mentioned, I love the fossil record and rock layers. And so here is a picture of me in Utah. This is like an imprint of a dinosaur footprint in some rock. All right. So let's go ahead, though, and talk about the fossil record a bit more. And as we move up the different strata in the rock layers, not only do we see we're moving closer towards the present, but we can see all of the speciation and biodiversity that existed in the fossil record and on Earth throughout time. But it is important to realize that not every organism leaves a fossil, right? It has to be kind of like the perfect conditions to leave a fossil behind. If you are an invertebrate, like a worm that doesn't have a skeleton, it's going to be very difficult to leave a fossil. You also have to kind of like die in the perfect conditions to like settle down and like fall into sediment and be buried, to be found in rock layers. Like if I like fell off a cliff hiking or something, most likely I'm going to be torn apart by scavengers. So you wouldn't most likely not find like an intact skeleton or fossil of me years down the line. Now, when we talk about the fossil record, though, there are some key things that we can look for. One of them being mass extinctions. So I've highlighted this yellow boundary between two rock layers. And what we can see is below this boundary, there's lots of biodiversity. Biodiversity means lots of different types of species. And above this line, it's pretty wiped out. So that tells us that at this time period in Earth's history, there was a mass extinction. So a mass extinction is where you have a lot of species going extinct at a very quick rate. Now, you can also look at 65 million years ago when the asteroid or the meteor struck Earth down in the Gulf of Mexico. That asteroid or meteor impact is really what led to the extinction of the dinosaurs. You can actually find elements that are carried on meteors from outer space in that rock layer. So that's a sign that something extraterrestrial struck Earth, and we can see above that there's it's pretty empty. Okay, so now though, we can also use a fossil record to calculate the background rate of extinction. So the background rate of extinction, the most simple way to explain this is that it's basically like, what is the natural rate that a species will go extinct? Now, if you already watched my video on punctuated equilibrium, I talked about how there's long periods of stasis, where on Earth, the Earth may be stable for long periods of time. So you have to think, why would a species go extinct if the Earth is stable and the ecosystems are not really that disrupted, right? So a reason a species may go extinct naturally would really only be if it was outcompeted. Without human interference, what would really cause it to go extinct? So the natural background rate of extinction is calculated to be somewhere between 0.1 and 1 species going extinct per million species on Earth per year. So for example, if there was 5 million species on Earth, 5 things would go extinct in that year. So a very slow or low amount for the background rate of extinction. Now, oops, let's move my face. So we can compare that background rate of extinction to like present day, for example. So our current background rate of extinction is 100 extinctions per million species per year. So we are losing our biodiversity 100 to 1,000 times faster than we would expect. So scientists say that we are living in the 6th mass extinction here on planet Earth. Our rate of extinction is incredibly high, and that's really due to a lot of ecological stress and rapid changes in habitat for the species we have here on Earth. Now, in Earth's history, we have had 5 mass extinctions, and a lot of times these mass extinctions are due to like I said, ecological stress. And so that could be due to climate change, like a rapid melting of an ice age or an ice age forming. It could be due to lots of volcanic eruptions. Maybe the pH of the ocean changes. Maybe it's an asteroid or a meteor striking Earth. But there's like some kind of sudden ecological change, and therefore the species that are living at that time, they may lack the genetic variation to adapt by natural selection. So when we think about evolution and species surviving, this is where having a high amount of genetic diversity and lots of variation in your species increases your odds that a few members will be able to survive changing environments. So right now, in our 6th mass extinction that we're living in, one of the leading cause of species going extinct is habitat loss. As the human population grows, we move into ecosystems, we cut them down, we have deforestation, we have all kinds of ways that we are reducing the size of habitats of species. And so therefore their habitat shrinks, there's intense competition, not all are going to survive, there's not enough food, etc. And so the species, as their population shrinks, they lose a lot of that genetic diversity and variation, which makes it harder and harder to survive. We'll talk in our ecology unit about the leading causes of extinction for species today. It's abbreviated as HIPCO. So you have habitat loss, invasive species, population growth of humans, pollution, climate change, and overexploitation or overharvesting. So humans are right now having a huge impact on our species and making it incredibly difficult for them to survive. All right. So I know this is kind of a general or a vague video, but hopefully it was somewhat helpful. Good job.